So how do we deal with Venn diagrams? And I wasn't supposed to say that. And I've lost my chain of thought and I'm probably supposed to stop and restart this recording, but I'm not. First thing that's come to my mind is do I start every video with the word so? That's terrible. So we're not gonna start with so and so, okay? And yeah, let's take two. Take two. Right. Okay. So task 31. I said so. I said so again. Let's not do that. Right. Be serious. Take three. Take three. Task 31. How do we deal with events that are not mutually exclusive? A situation where the probability of one event, in this case, the diagram we're looking at, event A, and event H, they're not mutually exclusive. So the probability of A plus the probability of H is not the method we can use to say if we're going to get A or H. And to put it in context here, as we look at the diagram, the powerful tool we're going to use, the Venn diagram, ace, and it's A is for ace. We're looking at a model of a deck of cards, and A is for ace, H is for hearts, and what's the probability of getting an ace? What's the probability of getting a heart? We can work out from this diagram. What's the probability of getting the ace of hearts? You know, that's why it's not mutually exclusive, because a card could be an ace and it can be a heart. So how do we deal with that overlap? We started to explore that. I touched on it a bit in task 30, and we want to formalize that and practice that skill of dealing with the overlap. That's what we want to do here. What we have in this particular Venn diagram are frequencies or counts. How many aces? I have 3 and 1, 4 aces. Look at where that 4 is coming from. That's not supposed to be there. The controls for the recording were blocking my pen. That presents a bit of a problem, doesn't it? If you have not realized, hint, 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 this is one of those videos being done at one of the crazy hours in the morning. So yeah, come on. Take it easy on me. Take it easy. Thank you very much. And you probably say, take it easy on me, sir. Take it easy. You know, come on, all this work on my home. Come on, come on. We're in this together. You and me, you and me. We're in this thing together, okay? We'll get through it together. We're a team. We are a team, I tell you. Right, so let's look at this non-mutually exclusive events, the use of the Venn diagram, how do we deal with the overlap? That first circle, the first circle we have here, that is every count, total frequency in the entire, and I'm saying circle and it's an egg shape, you know what I mean, okay? The entire circle is 4. So that because there's 4 aces, this is a deck of cards, 52 cards. We got the 52 cards. There's 4 aces. Ace of diamonds, ace of spades, ace of clubs, and ace of hearts. Yeah, I got the 4 of them there, right? So you can see the entire circle, 4 aces. Then if I look at hearts, and I should have put heart, really, that's really poor of me. Hearts should go in red, shouldn't it? Hearts, there are 13 hearts, 12 plus 1. So the frequency, how many hearts? 12 plus 1. There's one of the hearts that will be an ace. There's an ace of hearts, and there's 12 other cards, 13 in total. Okay, so you can see that there is that overlap, that one card that is both an ace and a heart. And that's the big useful thing that the diagram represents. So if I was to ask you now, what's the chance of getting an ace and a heart? You can look at it, and I said and the and is in the middle. It's the overlap when we use that word and. So ace and a heart, in this case, the frequency of that happening is 1. The probability, well, remember the probability is how many successful outcomes you want. So if I was to write probability of ace, and we will rub that off, that's not going to fit. Just going through how we can use this diagram. Pen. If we were to do now, what's the probability of getting an ace and a heart? What we're going to look at, and that probably might come up after, but it doesn't matter. I can do it now. Ace and a heart probability. What do I want? Ace and a heart. There's one of them. We can read that off. That can happen once. And then the probability, the denominator has to be the total number of options. And the total number of options, the total number of cards in this particular case is 52. They gave us the 52, but if they didn't give us the 52, how can you get it? You can actually add all the numbers up. Okay? There's 36 cards that are not aces and or hearts. So those are cards in the other suites. That's what the 36 means, because it's not in either of the circles. It's not an ace, it's not an heart. There's 36 cards like that. There's 13 cards that are hearts, 4 cards that are aces, 1 card that is both a heart and an ace. Yeah, both a heart and an ace. That's the idea we're going through. When I add all those numbers up, you get 52. You should get the total number of outcomes, possible outcomes, when you add up all the different numbers in the Venn diagrams. The numbers in the circles and the number in the rectangle. You always have to have that rectangle. And that E symbol, the E looking symbol, it is a Greek letter called epsilon, Greek letter, and that is meant to represent what we call the universal set. The universal set, all the possible outcomes, That's what that's supposed to represent there. Okay, so I've given you a description and started to give you a sense of how this Venn diagram can work, and we can see how the benefit for a non-mutually exclusive event, we make the overlap very, very clear. And that's really, really important. Let's look at, we're no longer going to look at examples. I've ditched the example bit now. I've called this P-1 practice or problem -1. In other words, I want you to read, or we'll read it together, and then we can have a go. Yeah, you see, I'm getting the hang of read it together, because we're gonna have a literacy moment. We're gonna have a literacy moment. Okay, right. So let's read it. In a class of 30 children, there are 20 who can swim and 25 who can ride a bike. And you can see we've built, I've given you we have a pre-built template of what the Venn diagram could look like. Riding a bike is for R is for riding a bike, and S is for those who can swim. Okay, and they make this statement: there's no child who cannot swim nor ride a bike. There is no child who cannot swim nor ride a bike. It is because of that statement, I'll put it in bold, Control B, that we have a 0 outside of the 2 circles. The reason being that there's no child who's not going to be either riding a bike or swimming. So 0 goes on the outside of the universal set represented by epsilon. Let's read together. Let's finish this. Draw a Venn diagram and find the probabilities that a child selected at random, 1, can swim and ride a bike. Key language, and. But this time, because we're using the Venn diagram, we don't have to multiply. Cannot swim, part B. Let's read together, and I tell you read together, and then I'm interrupting you. I'm sorry. Naughty step. Actually, sir, first warning, sir. You could do that, yeah. First warning, sir. You gotta write my name on the board, Mr. Phillip. Let's continue. Yeah, Mr. Phillip. Okay, you have a warning, sir. Okay, you gotta, yeah. Stop interrupting the reading, sir. Mr. Phillip, you have a warning. Yeah. Okay. B, we're reading from B, please. B, cannot swim but can ride a bike. And C, can swim but cannot ride a bike. Those are the probabilities we need to work out. And to help us work that out so we don't have to go into multiplication or any complex calculation with fractions, we can use the Venn diagram. All we need is to put in the numbers. How many numbers are riding a bike and swimming? How many numbers are riding the bike alone? How many is swimming alone? Those are the categories. That's what we're thinking about. Now we're told there's 30 children. So we know our total, when we add up these 3 numbers, we have to get 30. 20 who can swim, 25 who can ride a bike. And it's like, hang on, whoa, what's going on here? This whole circle has to represent 25. I'm going to put the 25 there. But this whole circle has to represent 20. There's 20 students who can swim. But if I add those up, what am I going to get? If I add those up, what do I get? What do you get? That's right, we get 45. But, oh no, we can't get, it's not 45 children. We know we have to get 30 children. We have to get 30 children, not 45. So how many are going to be in the overlap? And this is where there's a fancy thing called the addition law. At this stage, I'm not going to formalize it too much. That's going to come up in another lesson. But the general addition law, what the idea behind it, and let's take a commonsensical approach, is that 30 has to be equal to, I need to get 30 when I add the number riding the bike to 25 plus the number swimming, 20. And then we know there's going to be an overlap, so we need to think, well, what is the number I'm going to take off? How much do I have to take off to get 30? That's the model you build to find out what the overlap is going to be. So what's the overlap in this case? Exactly. It's going to be 15 because what do we have? 30 has to be equal to 45. Take away some number. What do you take away from 45 to get 30? 15. So the overlap is going to be 15. And I'll take off the two colors there. I think we're home free in terms of drawing the diagram. 15 is going to be the overlap. There's 15 kids who swim and ride a bike. Now, remember the whole circle, and I hate saying circle in this context when it's clearly not a circle, but ellipse, it doesn't, yeah, we stick with circle. Riding a bike, the total riding the bike was supposed to be 25. I already have 15. How much more to give me 25? 10. So there's 10 students, the interpretation, there's 10 students who only ride a bike. They don't swim, they just ride a bike. And then similarly for the swimming, there's supposed to be 20 students swimming. We already have 15 who swim and ride a bike. So that means to get to 20, how much more do I need from 15? When I add up all the numbers in the red section, that's for swimming, I'm supposed to get 20. I have 15, that means 5 is missing. 5 is missing. When we add everything up now, do we get 30? That's the check. If we add and we get 30, we know we're on to something. 15 and 5 is 20, and then 20 and 10 is 30. So do we have 30 children? Yes, we have 30 children. Yes, we have now drawn the correct Venn diagram. Now note, in future questions, you will not have the pre-built rectangle and the circles. You need to construct that for yourself. Okay, I've started off giving you a helping hand on that. You need to construct it and then go through that logical thinking process we've just gone through to get the numbers in. Now that we have the numbers, we've done this bit, tick, we've drawn the Venn diagram, we can use it to answer the questions. It's asked me to find probabilities. That means it is one of my answers. So can swim and ride a bike. That's in the middle. Is the answer going to be 15 then? This in the middle, the overlap is the and. It can do both. Another word we want to use there, both. Which students can ride and do both riding a bike and swimming. It's 15 students. So is the probability 15? No, it is not. Why not? Because the probability has to be a number between 0 and 1. Exactly. We want a fraction. So it's 15 ways to get a student who ride 15. We have 15 possible outcomes of students riding the bike and swimming, but it's 15 out of 30. There's 30 students in total, so 15 on 30, or if you want to simplify, it's a half. A half of the chance of choosing a student who swims and rides a bike is a half. Then now let's look, what section do we want for part B? Cannot swim but can ride a bike. They cannot swim, so we're not considering anybody. What does that mean? We're not considering anybody in the swimming section. Can't consider any of those people. Because they cannot swim, but they can ride a bike. If I cross out that, all the people who can swim have been crossed out. How many are left that could ride a bike only? Bike only. It's 10. We can see it there, 10. Is the probability 10? No, because the probability, the frequency, the number of ways of getting the outcome is 10. The probability will be 10 on 30. And I'm going to put it, I'm cramped for space, so I'll put the answers up here. For part B in green, I'm putting it up here. It's going to be 10 on 30, which we could simplify to a third. And then finally for part C, can swim but cannot ride a bike. So cannot ride a bike, that means everybody in blue, bye bye, disappear, not interested in you. I'm only interested in the people who can swim. Swim only. Swim only is the language we're thinking about. And that means it's 5. The number is 5, so the probability, it's 5 out of 30 kids, 5 out of 30 children, which you can simplify to be 1 on 6. That is your solution. And that is, we've gone through that whole process of how you can build the Venn diagram and then use it to answer probability questions. Very, very powerful tool in a situation where the events are not mutually exclusive. Let us do another one together. More you than me. So the power of the pause. I didn't mention it there, but I should have mentioned it. The power of the pause, and I want to try the next one. Let's go. P0. We did problem -1. Now we're at problem 0. That means it's gonna be, I'm gonna unleash you. Off you go from problem 1. There's 1, 2, 3, 4, 5, 6 of them I'm recommending that you potentially try. Yeah, I'm looking at 6 of them. Pause and have a go. I want you to try. You want to build up the whole thing. Build a diagram and get going. You use the power of the pause to get a head start on me. I am going to start working on it after I... Did I show you all my Tower of Terror Cop? I really like this one, so I wanted to share that. That's our little break, our little moment. You know, we just did our head in with a lot of logical thinking. This is from Disney, 2007, 8, 12, 13 years ago. And if I showed it to you, hey, I love my cup. I love my cups. So ever so often in a video, I'm going to talk about one of my cups, okay? So just get with the program. In Mets, sometimes we talk about cups. It's okay. Thank you. I just needed to say that. You know, we got to set some ground rules here about what is acceptable in online learning. And the teacher talking about things that are important to the teacher is important to you. Thank you. Right, that's off my chest. You use the power. Have you done the power of the pause already? What you waited on? Do the power of the pause and have a go. You did the power of the pause, and I'm sorry if you did it already, and I'm really sorry. You know, the thing with video is I don't actually know what's happening, do I? You know, I'm trying to work in my head what's happening, what you're doing, but there's lots of yous. You get it? So, okay, this is fun. I love this. I hope you're enjoying it. I know the for those of y'all watch, depending on I get it. Don't worry, I get it. I got 3 little kids. I definitely get it. Okay. Everybody's under 5, so you understand that now that is fun. Right, let's go. We're gonna draw the diagram. That's what you needed to do there. So I'm gonna get my rectangle. I'm gonna label my epsilon. I'm gonna put that E there for the universal set, everything, all the options. And in this particular case, it's a group of 40 students. So I know that when I add up all the numbers in this Venn diagram, I'm supposed to get 40. Okay? Group of 40 students. Okay, yeah, right. I was just making sure I did that right. And we have different categories. We have left-handed, and we have left-handed and size 7. So it's left-handed and size 7. So what I'm going to do, I'll make my 2 circles. I can get 2 nice circles. Now much. Oh, that's what we're talking about. Actually, you know, a circle mark. Circle, did the circle. Finally, I'm saying circles, and it looks like a circle. Not, come on, work with me. Yeah. Right, and then we do another one. Oh, man. That was hard. Okay. We do another circle. Oh. And why am I doing the same color when I have the opportunity to do a different color? So the next circle will be green. A green circle, yay, a green circle is what we're looking at there. And so those are the two circles. We have the overlap. It means nothing if one is bigger than the other. The only thing it actually means is I can't use my drawing tools as well as I should. I'm allowed to say that, not you. Okay, right, and we want left-handed, so I'll call it left-handed, and then size 7, I'll use a S for size 7, and those letters are too big, so left-handed and size 7. So we have the diagram set up. Now let's see if we can use the information to actually get what numbers fit in. 6 are left-handed, so that whole blue circle, when I add up both numbers, I'm supposed to get 6. 18 have a size 7, and this one is nice. They gave us the information. 2 are left-handed with size 7. They said with, but that with means is the same thing as and in this context. So there's 2 in the middle. 2 meet both criteria. That's why it's not mutually exclusive. You can be left-handed and size 7, and there are 2 students that meet that criteria. Now we're in a situation where I like to describe it as we're working inside out. So 2 are left-handed and size 7. We were told, however, that 6 students are left-handed. So how much are missing? The whole blue circle, when I add up all the numbers in the blue circle, I should get 6. 6 are left-handed, so that means 4 is missing. 4 is missing, okay? And then for size 7, we're told that 18, whoa, a whopping 18 have size 7 feet. So that means when I look at the green circle, I add all the numbers in the numbers in the green circle, the number of students in the green circle, I should get 18, but I'm only seeing 2. So what's missing? What's missing? How much do I add to 2 to get 18? Ta-da! I add 16. I add 16. And then I smile. Am I done? Am I done? I smile. I can start doing the dance. No. I can't. There's no more numbers when you start reading through the script. But did we use? I highlighted it, but I got to take off that highlighter because it's a group of 40 students. Have we used that 40 and have we thought about that 40 at all? No, but we have to. We have to think about that 40. And what color I haven't used? I haven't green. I haven't used. Group of 40 students. That means that my total has to be 40. What's my total so far? I got 16 and 4. 16 and 4 is my total so far is 16. Actually, no, I'll do it up here. So this is my first piece of working. I have 16 plus 2 plus 4, 16 and 4. You look for your number bonds, fast way to add. So I saw 6 and 4 would give me 10. So 16 and 4 would give me 20. This is giving me 22, but I'm supposed to end up at 40. How many students are not left-handed, not size 7? How many students are not left-handed or size 7? In other words, they're right-handed and they're not size 7. That's that because you're either left-handed or you're not left or you're right-handed, aren't you? But they didn't talk about right-handed. That would have been fun for a question. But how many? I need to get up to 40. So the second calculation, 40 take away 22, and that is going to be 40 take away 22 is actually the same thing as 38 take away 20, which is 18. Ever use that trick for your subtraction? Look at what I did there. It's easier to subtract with the 0, so you just decrease. No need for carrying over. No need to set it up as 40 take away 22 and carry over 1 and all that drama. The traditional things they show you all the time. You can use something we call shifting the difference. So 22, if you decrease it by 2, then you can decrease 40 by 2, and it becomes a much easier question to work with. Lots of little strategies you can learn. 18 is the missing number. Now when I add it up, I have 18 and 2. Using your number bonds, 18 and 2 is 20. 16 and 4 is another 20. 20 and 20, 40. Look for those zeros. I'm just showing you some ways you can do some quick mental to help you with your mental maths. Very useful skill to have. Right, now that we have our numbers, it all seems to work out. let's get our probabilities. What do we know about our probabilities? Can 18 be one of our probabilities? Can 2 be one of our probabilities? No. A probability has to be between 0 and 1, and if our total number of outcomes is 40, there's 40 students, the total in the Venn diagram is 40, then the answer to A, B, and C, all the answers have to have a denominator of 40. I mean, you can simplify the answers after, but I read this question. It doesn't say anything about simplifying, so we're just going to use 40. On this particular occasion, we'll just stick with that, because in an exam, if you did that, you'll get full marks. It'll be fine. So let us look at where we go from here. We have left-handed or had size 7 feet, or left-handed or had size 7 feet. So you could be in other words, what we're saying is you can be in the blue circle or the green circle. How many students do we have in the green or the blue circle? Or means you add all the numbers in the circles. 4 and 2 is, what am I doing? Bonds. What happened to my number bonds? 16 and 4, 20, 22. 22 out of 40 is the answer. Yes, you can simplify that to 11 on 20. If you have that, that's fine. And I know the number bond, it might not come naturally to you. You might just think, okay, let me add the numbers, keep going across. But spare a moment to look for bonds, to get zeros and fives. Very easy. The brain loves zeros and fives in its addition. So try and look for them, and you'll find your mental work will increase. You'll increase your speed and accuracy. Not left-handed and does not have size 7 feet. If you're not left-handed, you're not in the blue. You're not no size 7, you're not in the green. So not left-handed and not having size 7 feet means you're outside of the combined circles. The answer is 18 on 40. The probability is 18 on 40 because there's 18 students who are not left-handed and don't have size 7 feet. These are 18 students who are right-handed and, well, we don't know what size. All we know their size of feet is not 7. They're right-handed and they don't have size 7 feet. Those 18 students. That's what B was asking you about. And then the final one, not left-handed and has size 7 feet. Now you need to be thinking about, and actually, can I let me just do one more thing for B. B said not left-handed and does not have size 7 feet. Not left-handed, what I should have done to make it more graphic, not left-handed, and then doesn't have size 7 feet. We're not considering any of those. What is left to 18? So that visualizes B. Now let me do the same idea for C. Not left-handed. That means bye-bye. And we're saying, but you have size 7 feet. That means bye-bye, because out there you don't have size 7 feet. What is left? 16. The numerator is 16. The probability of somebody being not left-handed, not left-handed, but has size 7 feet and has size 7 feet, 16 on 40. If you simplified 16 on 40, you would get, whoa, that can go 4. What's the highest common factor? 4, so you'll get 4, whoa, 8. 8 is the highest common factor, which will give you 2 on 5, 2/5. 2/5 if you went all the way simplifying, and 18 on 40, 9 on 20. For B, 9 on 20 if you went all the way. And let's see, do I have anything I want to add to this at this stage? No. I think we are fine, right? Okay, I think that is fine there. So now it's off for you to do questions, and let's see what we will do as our questions. Let's get the whole thing going. Right, so first one up, and I'll let you have a go. It's a lot of reading, but you got to pause, use the power of the pause, read through the question. Then as it requests, you draw the diagram, you get and you work out the probabilities. So if you'll be so kind to work on question number 1, please. Now you will lose the power of the pause, and I will lose the power of the rock in my chair. Rocky, rocky, gony, gony. All sturdy now for me to worky. Yay. Okay. the diagram first. The diagram is critical. So this is what your diagram should look like. I've penciled that in, put that up for you, and we'll talk through it. How did we come up with this diagram? Well, we're told that there's 100 people. So key information, there's 100 people. So we know that the entire diagram, when I add up all the values, I should get 100. And you can see 40, 40, and 20, that's 100. Now, after the 100, the three figures we're given, the first of all is 20 watch neither, and the options we had were snooker and cricket. So two circles, one S for snooker and the other one C for cricket. And 20 watch neither, so 20 go outside of the circles. There's 20 people who didn't watch cricket or snooker, so they're outside of the two circles. Then if 20 are outside of the two circles, it means that when I add up the totals of people who watch snooker or cricket, so snooker only, cricket only, or snooker and cricket, I need to get 100 take away 20. That 20 can't count, so 100 take away 20. That's where we get the figure 80, coming up with the idea that these three sections, or the two circles overlapping, have to total to 80. Then we use the logic of that how do we adjust for the overlap? We were given 80 watt snooker, so 80. I know I have to get a total of 80. That's where that 80 is coming from, because 100 take away 20 is 80. But how do I get it? I have to add all the people who watch snooker, 80 people, plus all the people who watch cricket, because that's what the two circles will give me, 80 plus 40. And then I need to take away the overlap. And so the question is, what's the overlap? And when you work it out, if you have 80 plus 40, well, what are you going to take away to remain with 80? It's the 40 that has to go. And that's how we end up with 40 in the overlap, meaning that nobody watches cricket only. Everybody who watches cricket also watches snooker. That's what comes up here, using this technique of adding what the two circles add up to, and then taking away, finding out what number did we take away, what has to be the overlap, so that we get the exact figure we want. We know the two circles in total have to add up to 80, not 120. So what do I knock off? I knock off 40. 40 is the number that's being double counted. It's in the overlap. That's the idea. So it might look funny, you might feel uncomfortable putting 0, but it's right. Okay? We have 80 people. If you look at it, there's 80 people playing snooker. There's 40 people playing cricket. The only way it happens is if 40 people are playing snooker and cricket. There's 80 in total. Now, watch both. Both is in the middle. That's this section here, and I would use, both. Yeah, right. Both is in the middle. Cricket and snooker, it's both, and the probability of that, they watch both. We want the probability. How many people were there? It's 100. Don't forget your denominator. And 40 watched both, so 40 out of 100. The probability for A, 40 out of 100. Then watch cricket but not snooker. Cricket but not snooker. None. There's nobody watching cricket but not snooker. The answer is 0, okay? There's nobody who watched cricket only. Now, when you're using 0, you don't do 0 as a fraction. 0 stays there. And then what's snooker but not cricket? So snooker only, what you're thinking about there, snooker only will be 40. 40, so 40 is the quantity of the number of people watching snooker only. The probability of snooker only has to be 40 out of 100. So those are your three, yeah. Those are your three answers there. You could have simplified the fractions. 2 on 4/10 is 2/5, or 0.4, and 0 remains 0. If you put 0 as a fraction, you might lose credit on that. So that's question number 1 sorted. Okay. Now we want to look at the second question I want for you guys to do, and pause. Have a go. So pause and have a go again, please, and we'll talk about it after. Thank you. And let's look at this one. That's your diagram. These are your answers. Just a quick explanation for me. Look at what I did. I listed all the possible outcomes when you roll a fair dice. 1, 2. They didn't say fair, but they should have said fair or unbiased. 1, 2, 3, 4, 5, 6. Even number, there are 3 even numbers, 2, 4, and 6. There's 3 prime numbers, 2, 3, and 5, and you can see that overlap. 2 is the number that is even and prime. That is the logic that's used to build a diagram. So you get the overlap, the 2, one number. It's not 2, one number. 2 is the number, but how many? We're counting. How many numbers are even and prime? There's one of them. That means I have 2 numbers that are even only, 2 numbers that are prime only. That's 5 in total for even or prime, 5. So that means there's one number that's not even and not prime, which makes sense. You can see it from the listing here. There's one number that's not even or prime. So in many ways, this question, using this list and labeling, tagging all the numbers, is doing the job of the Venn diagram. The probability of E or P, it's the combination of the 2 circles, 5. And it's 5 out of 6 numbers in total. E and P is the overlap, and is the overlap, 1 out of 6. E but not P, that is where we are canceling out. We don't want P, so that's what we're left there. 2 on 6, which is a third. And neither E or P, that means outside of the 2 circles, so 1/6 the chance. Don't forget the big mistake happens a lot of times. People go putting the whole numbers, the frequencies, and not the probabilities. Read your question carefully. Okay. Number 3. Let's move on. Third one. Okay, right. This time I'm giving you diagram. You don't need to make the diagram. You need to interpret the diagram. But I've made it I haven't made it, but it's a bit more challenging. This time it's 3 circles. Yes, you're allowed to have 3 circles overlapping. They don't even have to overlap, to be honest. There could be 3 categories. There could be more. Use what we've learned so far to see if you can answer these. Off you go. Use the power of the pause. Obviously, I'll talk you through it after, but use the power of the pause. Right, you've used your power of the pause. You've worked through this. You've tried. Okay, and I'll just do a couple. I won't do the whole thing, or maybe I will, and I'll give you another one after. You'll see I'm picking up the pace now because we have the key ideas, and it's just applying it. And the more I do, you need to some of these things you need to come up with and discover yourself. Right. So A and B and C. That is where the 3 circles overlap. When we have it has to meet. So in this particular case, it's 3. Okay. So there are 3 events, 3 times that the circle we have that overlap. That 3 represents the number of successful outcomes. In terms of getting A and B and C, the 3 successes, but it's 3 out of how many? That's what we haven't calculated or read off. We don't know how many attempts or outcomes there are available in the diagram. We need to add it all up. We need to add all the numbers we can see. So 11 and there's no 9. Yes, 6 and 3 would give me 9. So I'm thinking number bonds. 11 and 9 would give me 20. Then the 8 and 2 would give me 10. So that's 30. Then the 5, 4, and 1 will give me another 10 and 40. No, the way I looked at that, I looked for my bonds to get my 10s and 20s, and you get 40 as your total. So 3 on 40, and we now know that 40 is my denominator for all of the other parts of the question, but before you simplify. So 3 on 40. A or B or C would mean any number in the circle, in any of the values in the circle, which means it's everything except the 11. If my total is 40 and I have to take out 11, what am I left with? I'm left with 29. So 29 on 40. A or B, what are we thinking about there? It's the combination of these 2 circles. That's what A or B represents, the combination of those 2 circles. So everything I'm keeping except 8 and 11. 8 and 11 is 19. What's left from 40? 21. So for B, we're going to have 21 on 40. Then A and B would be the overlap between A and B. It has to meet the both criteria, A and B. Note they didn't say A and B only. If they said A and B only, then we would want the 2. We'll have to ignore the 3 that touch into C. But they just said A and B, so it's where these 2 circles overlap, and that's 5. a total count of 5. So for D, we have 5 on 40. I'm not simplifying my fractions. That will be 1/8. It's not necessary. A or C, in terms of A or C, what have I deleted there? Messed up by 5. A or C, I'll erase that bit. And A or C, what you're looking for there is the combination of the two circles for A and C. Those are the numbers we now have to add up, which means 16 is not being counted. 16 is not being counted. We're left with 24. So for E, 24 on 40, which you can simplify 24 on 40. And then finally, F. What are we looking for F? F says probability of A. A would be the entire circle of A, all of this. That's the category we're looking for, the outcomes we want. Those are our successes. 4 and 2, 6 and 4, 10. So we have 10 on, for F, you have 10 on 40, which is a quarter, okay? 10 on 40, which is a quarter. Those are your solutions for number 3. Those are your solutions for number 3. Here is question number 4. Pause, have a go at it. Use your power of the pause. Very similar to the previous question. So you want to, it's the same probabilities you want to find, but the design of the diagram is different. So model what I did previously to come up with your solutions. Pause, you work on this one. And in terms of answers, here are your answers. I'm going to bring it up a bit. So if you'll be so kind to mark your work, the answers are there. Some of the fractions have been simplified, but those are the answers that you should have. So for example, the first one, A, 5 on 60 is what would give you 1/12. So those are the answers there. Let us go on to another one, and I'll say this one is optional. It's a bit of a stretch, this one. So if you want to go a bit deeper on this, you try question number 5, but for some of you all, you might want to go through and do number 6. So pause, have a go if you want to go a bit deeper on this particular skill. You'll notice this one is a bit different in terms of how the diagram is set up. So it's not the three circles don't overlap. What are the implications of that? So really good one to stretch you here, but it's optional. You should have had a pause and had you go. Yeah, you still have, yeah, okay, great. Now answers for this one here, your answers here. Let's bring it up a bit. So I use the word so too much. Bad habit. Right, you can go through your answers there. Mark your work, please. And remember, you're marking your work in a different color pen. Marking your work there. And then finally, one more. What I want to explore in this question. Here you go for question number 6. A very different style to what we've done before, using decimals, and critically, this question in the diagram, and we haven't looked at it as yet, but in a Venn diagram, you can represent probabilities. It doesn't have to be the frequencies. You can actually put the probabilities in the diagram and use the same logic to answer your questions. So that's the strategy you want to think about here to help you with this one. So off you go at number 6. This is a big, really nice one to finish off on this topic, and it's very much in the stretch area in terms of understanding of the concept. Yeah, okay, I'm gonna go through it now, and here we go. And I'll make some commentary on this one. I've set up a diagram. I haven't completed the diagram because I didn't need to. The answer is 0.558. So if you got 0.558, do the dance. Do the dance. Do the dance. Okay. What's the information we had in the logic? We have left-handed and female, and then they told us 0.042 are people who are somebody who's left-handed and female. That's what they're thinking. That's the way you want to interpret it. So 0.042 is the overlap, and then the question. Well, the question wants us to work out to select somebody who's female or left-handed. Female or left-handed is anybody who's left-handed or anybody who's female. So that's what we're trying to work out. What's the sum of the probabilities in both circles, some of the probabilities in both circles, which means we need to we know the overlap. We don't have to find it. We were given the overlap, but we need to use our understanding of the overlap, that the overlap is the bit that's being double counted, so it needs to be taken off. We get the we added, so what do we do? And this is your setup here. You add the probability of being left-handed, 0.08. 0.08 would represent the entire circle, but that 0.042 bit has to be taken off. Then we add the total bit of people who are female, so we're adding the totals. Probability of being left-handed plus the probability of being female, take away the probability of being left-handed and female. That's the general form of the formula. I won't have used, actually I can touch on you with the set notation. That's a separate lesson there, really. But intersection, that means the word and, L intersection, F, and the symbol for or is union. So having a U shape, F union L. So, and that's the general formula. I'll finish with that. You'll see what I've done. I've added two numbers and taken away the overlap. That gives you your answer, 0.558. The formal set notation and the general law of addition. We will explore set notation in a bit more detail in another task at some point. But the probability of A union B. Actually, I'll use this. I'll use the letters here. In this case, F union L. So union, that union symbol is what represents the word or. We don't use the word or in set notation. So this is the mathematical way we'll represent it. The formal mathematical way for me to finish up is equal to the probability of F plus the probability of L. Take away, I hope I don't, but I'll just make my picture smaller. Take away the probability of L intersection F. And that intersection is the symbol representing the word and. So that's your formal set notation. We've introduced that, but no need to use it. But for higher levels, you would need to be aware of it and be able to interpret it. Okay, that's it for dealing with non-mutually exclusive events.